MCP has become a requirement for building anything with AI. By the end of this video, you'll know what MCP is and what it isn't. In order to explain what MCP is, let's start with an analogy. Imagine you want to drink cafe latte, but every restaurant has a different name how to purchase one. So you need to remember that in restaurant 1, it's called latte, in restaurant 2, it's called cafe latte, and in the third restaurant, it's called milk coffee. 3 coffee shops, 3 different menus, latte, cafe latte, milk coffee. It gets confusing. It's too many patterns that we need to remember and handle. Everyone does it slightly differently. Now, this is one of the core problems that MCP tries to solve. LLM on their own aren't as capable. The real power is unlocked when they can talk to tools like your email, calendar, browser, and so on. So we need to enable LLMs to talk to these apps. And ideally, LLMs should use the same language to talk to different tools. Let me show you by an example. So we have the LLM client here, which is ChatGPT. And then we have email, calendar, and Jira. One of the key requirements for LLM to connect to tools and servers, let's call those servers, is to know what capabilities each server has. Email has capability to read your emails, to write emails, and so on. That calendar has the capability to schedule meetings, and that Jira has the capability to create tickets, for example. Now we need a way to discover those capabilities. Every LLM client connects to the servers and asks them, hey, what capabilities do you have? And for the email, it may write get tools. And before MCP for the calendar, it may actually say retrieve tools. And for Jira, it may say something like list tools. So this is like the ordering coffee example. We want to know the tools of every server, but in order to get those tools, we need to communicate it in a different way to every server. So one of the server wants get tools, the other server specifies retrieve tools, and the third server specifies list tools. It's just too many different languages. And when you scale this to many tools and many clients, we get an issue of lack of standardization. And I'll explain more what this means with examples, but the Model Context Protocol, or MCP, is like creating a universal coffee menu, a common language that every client and every tool can understand. So the first key strength of MCP is standardization. Everyone speaks the same language. Instead of every system inventing its own protocol, MCP gives us just 3 universal actions. First, MCP specifies, okay, every server would provide a way for the client to list all the tools. So the client would know what are all the capabilities for each server. And MCP also specifies exactly how the client would get this information from the server. And it's called tools list. Let's put it in green. So we don't have get tools, we don't have retrieve tools, we don't have list tools. Instead, every server and client would adhere to tools list, and nothing else. If you want to get the capabilities of the email server, you would have to call it with tools list. If you want to get the capabilities of the calendar, you would call it with tools list. And if you want to get the capabilities of any other server, you would call it with tools list. And those servers would respond with a specified schema that I'll show you later. But this is the exact same schema for every tools list call. So the client knows exactly what to expect in the response as well, and exactly how to parse it and so on. So first, MCP specifies tools list. Then when we get the list of tools from each server, then the client can call each tool with tools call. And I'll give you an example later exactly how this works. I'm just talking high level here. And whenever the client wants to read data, structured data from the server, the client would read it with resources read. And the whole flow would look something like this: tools list, tools call, and then result. This is how the client and the servers would communicate. And this flow and those calls and those namings, they would apply across the board between every client and every server. And by the way, it's also really good for developers because developers would know exactly what to expect as well. We've already touched a bit on this, but the second strength is discovery, the ability for clients to ask a server what tools it has and learn how to use them instantly. So let me give you a code example and it would become more clear. So this is a Python MCP server and it provides the capability to add 2 numbers. How it works is that we initiate the MCP server and then we provide a tool, which is addition. And then the MCP client, so this is the server and this would be running in one process. And this is the client, let's say ChatGPT. So this is a server. We start it Actually, the client starts this server because the clients like Cursor and ChatGPT, they start their own MCP servers. Then what they do is that they list the capabilities of each server, and then the LLM know, okay, these are the servers, these are the capabilities, and the LLM decides which one to call from all of them. I'll draw a diagram to make it more clear, but with code, it looks like this. A server has two tools, and a client calls it, and it lists all the tools, and the LLM remembers the tools and may refer to them later. But the response from list tools would look like this. We have the name of the tool, we have the description, we have the properties that we want, and we also have the output of the schema. So if we call the tool, how the response would look like. And then the client could call the appropriate tool something like this. MCP tool call add with the two arguments A and B, and then we can print the result. This was just an example how the protocol actually looks like, what schema is returned, and the shape of this schema would be the same for every client and every server, and the LLM would know exactly what to expect. The LLM would know to expect name field, description, type, input schema definition, and output schema definition. And it looked like this. Let's say that was our LLM, and it connected to, it actually started the MCP server, and the communication layer is the standard in and standard out. And I'll talk about the communication layer a bit later, but the flow was like this: list tools. The server returned the tools in a standardized schema, and it said, okay, I have add and I have subtract that you can use. And then the LLM said, okay, can you add those two numbers, which were A2 and B2? And then the server can add those numbers and can return the result, which is 4. And the LLM knows, okay, the result is 4, then I can display this to the user. And the capability to discover tools is something very central to the MCP protocol, because then LLMs can dynamically discover the capabilities of each server and can adjust the responses based on this. So if you want to know the weather and the LLM has connected to a server that has the capability to tell the weather, then the LLM would ask the server, okay, can you tell me the weather? And the LLM knows all the capabilities from all the servers that it's connected to, because it's central to the MCP protocol that every server provides the list of tools that the server has. Finally, I wanted to talk about the transport layer. MCP can run over HTTP, but it can also run locally over standard out and standard in, which is currently the recommended pattern, which is why MCP clients, most of them right now, start their own MCP servers, as the example I've shown here. To summarize, MCP standardizes how clients talk to tools. It makes tools self-describing through live discovery, and it enforces structured input and output so AI can reason directly. MCP also supports both HTTP and local stdio transport protocols. And I want to briefly touch upon what MCP is not. And I've seen this example on the internet. I want to explain why this is not MCP, but just a pattern that makes sense to be used with MCP. But in order to understand what MCP really is, we also want to understand what MCP isn't. Let's say we have 3 APIs that provide flight data, but in a slightly different shape. So let's mark them with different colors. So you can call any API, and let's say that's an LLM here. An LLM can call all the different flight APIs. Now, the example was that MCP server standardizes those APIs in a way that the client sees the exact same schema. So the MCP server would do a lot of standardization between the APIs, so the client sees the exact same schema. So let's say that each API returns number of flights to a certain city, and then they would say city Munich, and then bear with me for a second, I'll make the point right now. And this API returns it like this. So it was said that MCP would just standardize the way that the client always sees the exact same format. For example, this format here. This is not MCP. This is just a consolidation and standardization pattern to standardize 3 APIs. But this standardization could be done by any server. It doesn't have to be MCP server. It could be a REST API as well. It doesn't matter. What matters is though, and what actually makes an MCP server actually an MCP server, is that this server adheres to the protocol that MCP specifies, which means tools list, tools call, and resources read. As long as this server provides all those capabilities, then this is an MCP server. And the fact that it standardizes 3 APIs, it's just standardization pattern to hide complexity from 3 different API layers and to unify them. But if the server here does not provide those 3 tools, then it's useless for the LLM. So what's very important is that those 3 tools are provided, because now every LLM can actually connect to this MCP server and have a standardized way of accessing those APIs instead of LLM having to do the standardization themselves of the different APIs. But also very important part is that the server specifies those tools, if that makes sense. Sorry if that got a bit confusing. I just want to say that hiding complexity from the clients is something that every server does or should do. What makes a server MCP is the adherence to the protocol that MCP specifies, which is roughly speaking providing all those methods. As long as they are provided and other MCP specifications are respected, then this is an MCP server, otherwise it's not. And right now, in order to build almost anything in AI, you need to understand what's MCP server and ideally to have built a small one just to have a sense of how it looks so that you can extend LLMs with different capabilities. And in my next tutorial, I'll implement a small MCP server so you know how that looks like as well. Thanks a lot for watching and see you next time.